In section 4, the last shapes we have to talk about are kites and trapezoids. So we're going to start off with a trapezoid, which is a quadrilateral with only one pair of parallel sides. There's also something called an isosceles trapezoid, and that's a trapezoid whose base angles are congruent. So if we're looking at our trapezoid here, we have our pair of parallel sides. The base angles are the pair of angles at the bottom, which would then be the congruent, and the pair of angles at the top, which would be congruent if it were an isosceles trapezoid. So we have two theorems relating to trapezoids. The first being that the base angles of an isosceles trapezoid are congruent. The second one is that the diagonals of an isosceles trapezoid are congruent as well. Now, these two theorems only apply to isosceles trapezoids. So if we have a regular trapezoid, so it just has a pair of parallel sides, the diagonals are not congruent in that case. So we're going to go ahead and mark all of the congruent parts of our isosceles trapezoid. So we know that the base angles F and G are congruent, and also base angles H and I. We also know that the diagonals HG and FI are congruent. Now, when the diagonals intersect, it splits the diagonals into congruent parts. So that means the two shorter pieces are congruent to each other and the two longer pieces are congruent to each other. And again, it's important that we are talking about isosceles trapezoids here. This is not for any trapezoid. This is specifically for isosceles trapezoids. So next we're going to talk about the midsegment of a trapezoid. So the midsegment of a trapezoid is the segment connecting the midpoints of the non-parallel sides. And there's a theorem that has to do with the midsegment, and that states that the midsegment of a trapezoid is equal to half the sum of the parallel sides. So in our shape here, if I were to label the midpoints of our midsegment M and D, I would get the equation that MD equals 1/2 of HI plus FG. So that's basically the theorem written as a formula. So let's go ahead and do some examples. So we're going to use that trapezoid. We know that HI is 12 and FG is 30. What is the length of the midsegment? So if we go ahead and label, HI is 12 and FG is 30. So using that formula I just wrote, we have that MD equals 1/2 12 plus 30. So we end up with 1/2 times 42. So we get that the midsegment has a length of 21. Now the last shape we have to talk about is a kite. And a kite is a quadrilateral with two pairs of adjacent sides congruent and one pair of opposite angles congruent. So when we're looking at the figure below for our kite, the adjacent sides will be OU and UT, so they are congruent, and then OP and TP, they are congruent. And there are a pair of opposite angles that are congruent are going to be angle O and angle T. Next we have stuff about the diagonals of a kite. So the diagonals of a kite are perpendicular, which means when they intersect, they form right angles. So go ahead and label that in my picture. We also know that the angle contained within the congruent adjacent sides is bisected by the diagonal. So what that means is that angle U and angle P are bisected by our diagonal. So it creates congruent angles when the diagonal passes through those angles. So let's go ahead and do some examples. So we want to find the measures of angles F, H, and I if the measure of angle G is 70 degrees. So we know that angle G is 70 degrees. We also know that because this is a trapezoid, HI is parallel to FG, which means we can think of IG as a transversal, which means that I and G have to add to 180 degrees, which means angle I is 110 degrees. Okay. If this weren't an isosceles trapezoid, we would then be stuck. We wouldn't be able to find angles H and F. So we're going to assume that we have an isosceles trapezoid here in order to find the measures of H and F. So base angles are congruent. So since angle G is 70 degrees, that means angle F is 70 degrees. Angle I has to be congruent to angle H, which means that angle H has to be 110 degrees. Next, we want to find the value of X in our isosceles trapezoid if Fi is equal to X plus 1 and Hg is equal to 2X minus 3. Fi and Hg are the diagonals, and in an isosceles trapezoid, diagonals are congruent, which means that X plus 1 equals 2X minus 3. So we're going to subtract X from both sides. So we get 1 equals X minus 3. We're going to then add 3 to both sides. So we get X equals 4. In our last example, we want to find the measures of angles 1, 2, and 3 in our kite. So we're going to start with angle 1. Angle 1 is where the diagonals intersect, and in a kite, all diagonals are perpendicular, which means that the measures of all 4 angles there are 90 degrees. So the measure of angle 1 is 90 degrees. Okay. Angle 2 is at our vertex U, and we know that when diagonals intersect our adjacent sides that are congruent, it bisects them, which means these 2 angles are congruent, which means the measure of angle 2 is 46 degrees. Lastly, when we want to find the measure of angle 3, we're going to use our right triangle OVU to find that measure because we know all 3 of those angles have to add to 180. So if we do 180 minus 90 minus 46, we get that the measure of angle 3 is 44 degrees. So as you're working over the section 4 assignment, please feel free to ask any questions that you may have.